engineer at Harvard University, and this is my BattleBot, Brutus.
I have a pretty fun job. I'm a PhD neuroscientist who's a self-taught engineer. I got involved with BattleBots because a good friend of mine who I've built another robot with said, "Hey, you want to build a fighting robot?" I said, "Absolutely."
I'm an engineer today only because of competing in BattleBots since my childhood. I made a few little things that resembled robots in the beginning that didn't work. I started a few fires and eventually made something that can move and bigger and badder and eventually something like this. I've never stopped building BattleBots since I started, and I hope I never have to. Watching the best old builders compete and reading their build reports, I saw many of them had designed their robots in 3D before building them. The robots were getting more compact and more feature-rich, and Solidworks was one of the tools I saw popular among the best builders, and I decided that I needed to learn Solidworks to build the best robot I can build.
Learning Solidworks for me was going solo at my desk every single morning. Once I decided that this was a tool that I needed to learn, I could see the power there. I went after it, and now, years later, it's amazing what I can do with it.
Brutus is designed as a kind of all-around robot, fast, strong, powerful, and we can take any situation with full force. The most powerful advantage Solidworks gives you is the ability to rapidly iterate digitally without cutting any steel. Brutus here is the first version of Brutus that's ever physically existed, but maybe the fifth version of Brutus that's ever existed conceptually, and Solidworks helped me get there.
One of the more useful things for building robots is the mass tools, where finding center of mass quickly turns out to be very useful. Also getting an idea of the weight of something quickly, being able to change those properties has been very useful for me.
There's a lot of pressure. Spending so much time and energy creating something like this, knowing that it can all be shredded in moments right in front of your face. And the moments before a fight are pretty intense. You do your best to stay calm, visualize your fight, visualize your opponent, imagine what you're going to do, and go out there and try to execute the best you can. I mean, things will change. Your plan, without fail, will fail, and just adapt or die. I'm Adam Verku. I'm a neurotechnology engineer at Harvard University, and this is my BattleBot, Brutus.
I have a pretty fun job. I'm a PhD neuroscientist who's a self-taught engineer. I got involved with BattleBots because a good friend of mine who I've built another robot with said, "Hey, you want to build a fighting robot?" I said, "Absolutely."
I'm an engineer today only because of competing in BattleBots since my childhood. I made a few little things that resembled robots in the beginning that didn't work. I started a few fires and eventually made something that can move and bigger and badder and eventually something like this. I've never stopped building BattleBots since I started, and I hope I never have to. Watching the best old builders compete and reading their build reports, I saw many of them had designed their robots in 3D before building them. The robots were getting more compact and more feature-rich, and Solidworks was one of the tools I saw popular among the best builders, and I decided that I needed to learn Solidworks to build the best robot I can build.
Learning Solidworks for me was going solo at my desk every single morning. Once I decided that this was a tool that I needed to learn, I could see the power there. I went after it, and now, years later, it's amazing what I can do with it.
Brutus is designed as a kind of all-around robot, fast, strong, powerful, and we can take any situation with full force. The most powerful advantage Solidworks gives you is the ability to rapidly iterate digitally without cutting any steel. Brutus here is the first version of Brutus that's ever physically existed, but maybe the fifth version of Brutus that's ever existed conceptually, and Solidworks helped me get there.
One of the more useful things for building robots is the mass tools, where finding center of mass quickly turns out to be very useful. Also getting an idea of the weight of something quickly, being able to change those properties has been very useful for me.
There's a lot of pressure. Spending so much time and energy creating something like this, knowing that it can all be shredded in moments right in front of your face. And the moments before a fight are pretty intense. You do your best to stay calm, visualize your fight, visualize your opponent, imagine what you're going to do, and go out there and try to execute the best you can. I mean, things will change. Your plan, without fail, will fail, and you just adapt or die.
Hello and welcome everybody to Solidworks Live. Whether you're joining us on Facebook, YouTube, LinkedIn, Instagram, or live.solidworks.com, we're really glad to have you here today. I'm your host, Jeremy Rigneris, and today's episode is going to be really fun. We're going to be meeting team members or team leaders from 3 different BattleBots teams. So hopefully this is going to be really exciting. I'd like to welcome each one of these members on and talk a little bit about them. I'm going to start with Jamison Go from SawBlaze. Jamison, welcome to SolidWorks Live.
Yeah, Jeremy, thanks for having me.
So for the folks at home who maybe haven't watched BattleBots in a little while or haven't watched it before, tell us a little bit about SawBlaze and what makes SawBlaze special.
All right. Well, SawBlaze, you can see in that team photo there, is the black and green robot. It's kind of characterized by this sort of capture dustpan architecture where it has these 2 wheels that drive the robot around, but a whole lot of steel in the front to sort of entangle with bots in a way and get underneath them to essentially control them, pin them against the wall, and then attack them with this overhead weapon. So it's kind of listed as a overhead saw. We have a variety of different blades that it can apply depending on the opponent, but in any case, it spins and it goes over the top. Another thing that is characteristic for this robot is it has a flamethrower. That's the blaze part of the SawBlaze. It is green colored. Thanks to our flame engineers on the team, we have a green flamethrower that burns pretty darn hot. So
if people want to learn more about SawBlaze, where can they go to find more information about your robot?
SawBlaze has 2 primary social media pages. We have a Facebook and Instagram. The URLs are listed down there at the bottom. So feel free to check those out so you get the latest on SawBlaze as we, prepare for really about anything that might be coming up.
All right. Next, I want to welcome the robot Huge, and I want to welcome Jonathan Schultz to talk a little bit about Huge. Jonathan, welcome.
Thank you for inviting me.
So Jonathan, right away I can see, your robot looks a little bit different. Tell us about what makes Huge unique in BattleBots.
Yeah, Huge is, it's a very different take on robots. So what our design philosophy is to put all of the fragile components, all the important components about 1.5 feet off the ground, and really challenge people to come up and come hit it. Because 2/3 of the robots in the field couldn't reach that even if they wanted to, and the other third need to get past our spinning blade to get to it. In the middle is a 30 to 40 pound bar of steel. It's a 3-foot long rectangle, basically, spinning at about 200 miles an hour at the tips. So once that's fully up to speed, the idea is that it's going to throw people away from the body, it's going to do damage to opponents, and it's going to keep us safe. And that's our primary armor, but otherwise we're riding on these 25-pound big plastic chunky wheels. And those are kind of our trademark at this point, where we use the wheels to keep people away. We use the wheels to take hits and dissipate energy. They're really multi-purpose, and that's kind of our main design feature is the big wheels.
All right, really quick, we just threw a poll out there. If you're joining us on YouTube, you can participate in that poll, whether or not if you do you watch BattleBots. Jonathan, while I have you here, really quickly, where can people go learn about Huge and your robot in more detail?
So we are at BattleBots Huge on every platform, and then hugebattlebots.com, the website, and watch the show. It's funny about it.
I love it. So next, I want to, we've seen two very deadly looking robots here. I want to bring up one more. I want to bring up Brandon Zalinsky to talk about P1. Brandon, welcome to SolidWorks Live.
Hey, thanks for having me today.
So Brandon, your robot looks a little bit different than the other ones I've seen. Tell us a little bit about P1 and what makes it so unique.
Yeah, so P1 is definitely in the minority in that it does not have a spinning weapon. So we don't have some big piece of metal storing kinetic energy to dump into other robots. And instead of that, we have a very, very fast, very powerful drivetrain and a lifting weapon that hinges forwards. So we get under other robots and push them up forwards, flip them over, flip them into walls, flip them over the walls, flip them into arena hazards. There's little areas around the arena that have hammers or saws coming out of the ground or screws that can pull a robot out of the arena. So essentially what we do is control the other robot, take 1 million hits, and break robots that have spinning weapons, try to break their spinning weapons.
All right. If people want to learn about P1, where can they find information about your robot and your team?
So much like the other two teams, we have both a Facebook and an Instagram. We're both Aberrant Robotics, which is our team name, because we've had a couple of different BattleBots. And we have a couple different smaller robots as well, kind of all under the same umbrella. And when you're there, you can get a link to our YouTube page as well. It doesn't have a custom URL because we don't have enough subscribers. So you should go and subscribe to that. And you can also see daily build time lapses of us building the robot right here in our build space there. So check that out.
Oh, it's really cool. And I'm glad you're joining us from your build space there. In fact, is that what we see in the tell us a little bit about what's in the background right there behind you.
So this is the first appearance of the 2021 P1 robot. So this looks very similar to the robot that was in 2020, but there's a lot of pretty significant differences, especially internally. And if you look even closer, you can see in the corner back there, you can see our second chassis and our second wedge kind of hiding back in the corner. So this is, well, I'm sure we'll get into it a lot more, but this is going to be our robot that we're competing, hopefully, for the next season of BattleBots.
All right. So I'm glad all three of you are joining us here today. And for those of you joining us on any platform, if you have questions for Jamison, Brandon, or Jonathan, please post those in the comments. Join us in the live chat on YouTube or the comments on LinkedIn and Facebook. I'll be paying attention to those and we'll throw those questions out to our guests. So with all three of you here, I have to ask, is this going to become a grudge match while we're on SolidWorks Live today? Or do you guys actually get along with each other? I'll go to Jamison on this question to start.
Oh, I hope not. I mean, you're not going to try and pit us against each other on the SolidWorks Live, are you? Now, we're all pretty great friends outside of it. You know, we see each other a lot in some of the, say, amateur weight class tournaments. We fight in the box, but, you know, outside, I'd totally get a beer with these guys. They're great fellas.
Jonathan, how about you? Are you going to be okay with your fellow competitors next to you?
I think definitely. It really is. It's, you know, yeah, the community is based around fighting robots, but we are all doing the same hobby. We all have the same interests. So it's a really easy way to make fast friends when you show up at a BattleBots event. And I know all these guys have known them forever. So I think we'll be friends.
Brandon, how about you? Are you here to learn something about your fellow competitors' future robot designs?
Yeah, I mean, I'm the only one who actually brought something. I was looking in the background to see if I can see some pieces of other people's robots, but apparently I was the only one who did. I'm disappointed. No, and it's a very kind of mixed thing because we have around at a BattleBots event you'll have around 300 people. So I mean, you can never get 300 people to agree on anything ever. So there's always going to be some like personal kind of people just don't really get along with each other. But the good thing is that if they're on different teams and such, they're over there, you're over there. It's not a really big deal. And it's just like any other competition. And emotions, and people have tons of time and money invested in these robots. Emotions will run high sometimes. In the moment, you really may not like somebody, but in the end, a lot of people will kind of be like, okay, that's our in the box rivalry. We will go out and grab dinner and talk about how good the fight was after the fact.
So it's kind of a grudge match in the cage. You get out, you shake. Maybe you need a couple minutes to calm down after a defeat or a win, depending if you're celebrating or commiserating with your teammates on there. That's great. I mean, so we have a couple questions from chat. I want to quick jump over to here. Brandon, we can see you're working on a build right now. Brian Zayas in chat asks, how many hours a week do you spend on all things BattleBots to compete at your level?
Well, during right now is the absolute peak of the amount of work that we put in between now and hopefully when we film the next season. But right now, I'd say weekdays, I work probably 4 days a week, about 4 hours a day, so about 16 hours there. And then about 12 to 20 over the weekend. So right now it's a ton of time in order to get a robot or multiple robots functional for the event.
How about the rest of you, Jamison? I know you're actually reporting in from your day job. So do you leave there and do you have to go home and work all night on SawBlaze?
Well, I mean, basically, yeah, it's the amount of time we put into it is basically like a second job. It's like a second engineering job, and mix in a little bit of the art aesthetics and the management into it as well. Yeah, I'm calling here from my work because that was the best, easiest way for me to jump right back into doing my job after this. But also, I'm very fortunate that my company is a sponsor for our team. And they let me use some of the facilities as well to do some fabrication, and have actually made parts for the robot on our own technologies. So,
all right. Oh, I kind of want to jump back into what we were talking about a moment ago. We were discussing community in a few ways, and it sounded like though the competition takes place, a lot of you get along with each other after the fact. I'm curious, do you ever run into cases where the community has had to come together to maybe even help another team? Is the community that tight knit where maybe somebody has a problem and somebody has to, you actually go help your fellow opponents? Is it that tight knit of a community? I'll let Jonathan, I think you had an answer to that, right?
Yeah. In almost every case, it is that. There's a few I can point out. They did a spin-off show for the 2018 season called BattleBots Resurrection. And there's an episode where I think 10 teams all work together to fix a robot. And that's real. That's, Veilspear went in the box, burned up a motor during their Twitch check, and they had to rush it back. And all these teams jump on it, get the top off, get the motor out, run the new chain, everything. And they got it back in the arena really quick. But also it's, a lot of the story of how my team grew to be Team Huge. It was just originally me and a couple friends at events with the littler version of Huge. And then once it broke, we had some people who ran over to help us fix it because they thought it was cool. They didn't know us. And those are the people who ended up being my teammates on the team. So it's a great way to find people who are energetic and excited and like the design. But it's a lot of what that world is we're all interested in the same stuff. We all want to see the robots do well and perform to their potential. And if that means you have to help a competitor out, that's part of the community. That's part of how it goes.
Brandon, how about you? Have you ever seen, I guess it's not just helping. Have you ever seen anything kind of turn into more of a mentorship? Have you ever had it where maybe a team couldn't participate and yet maybe you've taken somebody under your wing, or you've kind of gone and worked underneath somebody else?
Yeah, absolutely. So, I mean, for one thing, us and another team, Valkyrie, are very, very close. We share a lot of stuff. We share information, how we solve certain design problems. So a lot of the stuff that's, even though our robot and their robot, if you go and look up their robot, do not look similar at all. There's quite a few design problems that we solve very similarly, because they'll do something and we'll do something, and our part breaks and their part doesn't break, and I'll be like, all right, so mine doesn't work, theirs works. Let's figure out how to make ours work like theirs. And then the other thing is that every year there's hundreds of teams that apply to BattleBots, and only 60 to 80 teams get in per year. So there's a lot of teams, and even teams that have competed in the past, that don't get in. So this year we actually have kind of drafted 2 team members from a local team that didn't get in, that was in last year. And the hope with them, they're both really passionate about it. They're huge into combat robotics. They are both very willing to learn. So they're really great team members. So my hope with them is they'll help us get this build done. And then also they'll be able to take some of that information back to their team for next season to do the same kind of thing that we do with Valkyrie. If they look at something that we do that works, maybe they can go and take that and use that on their team.
So you're basically fostering your future competitors. Let me throw that over to Jamison. Have you ever dealt with anything like this where you were mentoring somebody or fostering a future competitor?
Oh, I have a little bit of experience in that realm. I mean, to that point exactly. I mean, one of my favorite stories that BattleBots has actually played up in the last season is my former mentee, Alex Satori, where my teammate Lucy and we first met him. He was a freshman at MIT and was introduced to combat robotics through our own activities. We were very active in the smaller weight classes at the time. And he immediately was hooked. He built robots basically every other day, and he was just so excitable. He learned so quickly. We had him on the SawBlaze team in 2018. We brought him over. He couldn't stay the entire time because school is very important. But in the future years, he had enough experience and, enough of a drive. He wanted to make his own team. So he took a different spin with some similar characteristics from what we learned in SawBlaze. He made his own team, which is Uppercut, and has become phenomenally successful. We had the grand pleasure of fighting them in the 2020 as a mentor-mentee sort of matchup, and he completely whooped us. And despite how the match went, I could have hoped for a better fight myself, but I couldn't be prouder for him. And he's just one of the great success stories, I think.
Well, that's really cool to hear about how committed this community is to supporting each other. We have a great question from chat here. I'm going to ask everybody this. We can go to kind of that full, all 4 cameras. This is a really good question. I'm going to put you all on the spot. It's from Cliff Medling on YouTube. I'm going to start with you, Jamison. Who is the robot you're most afraid of fighting?
Oh man, robot I'm most afraid of fighting. I don't know if there's a robot that I'm particularly afraid of fighting. I think we fought a lot of the tough robots already. I think the big spinners, for sure, like Tombstone or Uppercut, the ones that charge up, it could all be over in one hit, I think are probably the scariest to fight. But, strategically, another control bot, I think, would probably be a very even challenge. And those are the hardest to predict. So I don't know. Maybe Huge gives me the spooks just because he's just so out there.
Brandon, how about
It's
you?
mutual.
Is there a competitor out there that keeps you up at night?
Yeah, I mean, the dominant vertical spinners that have won a lot of the championships, I would not want to fight. Bite Force or Endgame sees teams who are not only have very reliable robots, but have very dominant robots and understand what they need to do to win fights and don't make dumb mistakes, especially in big spots. There's a lot of teams that will kind of maybe be a little over aggressive and make a driving mistake, and you can capitalize on that, especially as a control robot like mine is. But if there's a vertical spinner like that they understand that all they need to do is keep their weapon pointed towards you, and there's not a whole lot you can do, that's really, really hard to beat. So I would say Bite Force or Endgame, some of those dominant vertical spinners.
All right. Jonathan, so your robot's classified as a spinner, right?
Yep.
So it sounds like they're both kind of inadvertently saying Huge in a way, maybe. But how about you? What keeps Huge up at night and concerned?
If we do our job right, they will be afraid of it. So for us, the robot we are and will forever be the most afraid of was who we fought first in the 2019 season, which was a robot called Son of Waiachi. It has this 120-pound spinning cage with hammers on it over the top. So there's nothing for us to hit that's not the spinner. The spinner weighs 4 times as much as ours does, and the entire cage is wider than the wheels are apart. So it's a matchup we can't touch, and he's perfectly designed, and he tore our wheels up. We lasted a long time fighting, and we took a lot of hits, and we learned a lot that we think it would go better if we fought them again. But it's so far from ideal with that matchup that it's somebody where that's the design characteristics that we're the most afraid of. I have a wheel here with some slices in it, and what we're designed for is to take slicing hits and stuff like that, and that's most opponent robots. But when it's, he's spinning a meat tenderizer, basically, it was a whole different shape that we've never had any experience with before, and it was able to grab and just rip the wheel literally in half. And that was the end of the fight right there.
Oh. All right. Well, you talked a little bit about design there, Jonathan. I want to dive in and talk a little bit about kind of the design process when we're thinking about BattleBots here. So when you look at a new season, so many of you have been competing for several seasons. Jamison said he'd been competing for a very long time. What does that iteration process look like? Are you starting from scratch each year, clean piece of paper? Are you taking your existing chassis and building on it? How does that kind of go? Brandon, why don't we start with you on this question? Let's talk a little bit about what goes through that design process as you go through each year.
So first off, you got to look at kind of what you had last season. And that's not only what you have as far as hardware, like pieces left, what you have for stuff left, and then also who you fought, how you did, and how the fights went. So there's all this information that you kind of have to put together. For us, we trashed almost all of our parts. We had basically one full working robot left at the end of everything, but we were starting to run really low on spares. So at the end of the season, we basically said, okay, we don't have a bunch of parts to carry over, so we can kind of afford to change a lot of things. So with that information in hand, we looked at how our fights went and kind of figured out what our priorities needed to be for the next season. And the biggest thing for us was that for a robot that is no spinning weapon, that has no ability to throw a robot 20 feet in the air, we need to be able to never die, period. And losing quickly and getting knocked out quickly is unacceptable. So that was our big thing going into this year, is that looking at what killed us in the fights that we lost and how to fix those. So the biggest thing for us was the wedge. So the wedge was already very heavy and very tough, but we found that if you hit it in the right way, it could break a lot of the bolts that held it on. It could break welds at the corners of the wedge. So we redesigned everything with regards to that to say, okay, well, these vertical spinners are incredibly dominant and have won 4 out of the 5 seasons of BattleBots. How do we make it so that we can go 3 minutes in a fight against a vertical spinner and not break down, not break apart, and be able to just beat against them for 3 minutes and have them break before we do?
So you had, we were talking earlier, you actually said you ran into a situation in a competition where something happened, you literally had bolts sheared off from your last design, and that was something that was kind of what you were talking about, really wanting to reinforce there?
Yeah, exactly. So we got hit by Copperhead last year, which is a robot with a 75-pound spinning drum on the front of their robot made of S7 tool steel, and it's crazy powerful. And we just took a bad hit. It was a bad driving decision on my part. I took a bad hit, and this front wedge last year was held on by 14 3/8 bolts, and it sheared 12 of the 14 bolts. And so we looked at that and said, okay, this is not going to work. It works against most robots. It works against big horizontal spinners. It works against control robots, but does not work against these vertical spinners. So we redesigned all of the structure with how, all you see on the front is this big plate on the front, these 2 plates on the sides. But you can kind of see in our SolidWorks CAD, there's a lot of stuff kind of going on as far as tab and slot that goes on under it. So we've put a lot of effort into making it so that those bolts we use less larger heart. So we use fewer bolts, but larger. And we use geometry under our wedge that makes, that loads our fasteners in a significantly more advantageous way. We had a bunch of stuff in shear that really wasn't ideal last year. We looked at everything this year from if we get hit by a vertical spinner, how do we make the wedge not fly off? So that was the big perspective and the big updates for this year.
One of the other things I think you had mentioned is you kind of looked at that design of how your wedge actually works, making it as compact as possible. Like you kind of, was it a redesign or was that just a significant part of the design that makes P1 significant, that gearbox that you had?
The lifter gearbox. So this is a picture of our lifter gearbox. Since we are the shortest control robot at BattleBots and only the second shortest or third shortest robot, shortest meaning literal height off the ground, robot there, it means that we're very limited on what weapon systems we can use. So this was kind of our solution for 2021. It's very similar to our 2020 solution, but how to package a lifting mechanism in an incredibly complex or incredibly compact situation. You can see here we have a lifter motor into a gearbox, onto a chain, back into another gearbox, and then that final chain on the left, that final sprocket, goes to our lifter. So right. It's a very, very compactable system, and it allows us to lift robots up over our head.
So I think this is a great image. If you really want to get an understanding of how sneaky P1 is and can get under other robots, this is a great image. You can really, you have such a lower profile than a lot of the competitors out there, and that's like your big advantage to the robot, right?
Yeah, absolutely, and it's definitely our biggest design challenge too, because there's a lot of motors and a lot of batteries and stuff that we'd love to use, but we can't because they're too big. And there's something kind of big in BattleBots when you go from year to year. You want to kind of maintain the same imagery and the same kind of vision over the whole robot, even as you go through years. You can make changes to the way the robot looks, but you kind of want to make it generally stay the same. And there's a lot of things that we could have sacrificed and said, okay, well, we'll be taller and we'll put these motors in and it'll be cool, but it won't really be P1 anymore. So that's kind of something we've tried to stick to, is the same wheel size, the same chassis size, and as like a similar kind of wedge geometry.
All right. I'm going to go to a couple questions here on chat. I'm going to save one of these for later. Dallas Salad, I'll save your budget question until we get towards the end there. Remind me if I don't come to it. There was a question that I saw here that I really wanted to ask. Just a lot of people. Oh yeah, love it. Grown people talking about fighting robots. It's a great comment that I see right there. Jamison, I want to go to you. I want to talk about your design iteration process. You have a very iconic look. You know, Brandon just talked about maintaining the look and feel and the function of your robot. Tell us a little bit about SawBlaze and that design process and that iterative design process that you go through each year.
Yeah, that's right. For every one of these BattleBots robots, I mean, we're kind of battling off screen, this sort of function over form and combination of such. Each one of these robots is sort of like its own character on the TV show, and you want to make those characters memorable. So sticking with a design which maintaining the same core features which make your robot defined and recognizable are important for every one of our teams. So making modifications but not straying too far from what that robot looks like is important for us. The most complex thing really is thinking about the initial design. And for, each one of us has their own inspirations. I looked to a lot of former competitors to think about what's super cool that I was behind that could be also unique. Excuse me. At the same time, in terms of how we improve every single year, I mean, that's a little bit of understanding what do we want to do better from previous years. So we sort of have a feedback loop in terms of design. Every year we compete, we fight different robots, and something will happen. We'll win, we'll lose, maybe we'll lose big, maybe we'll win big, or somewhere in between. Every single match you can understand what exactly went well, what went wrong, and then what are some next steps to try to address those. My team, every single match, we do a tear down synopsis sort of thing we look at different aspects and characteristics, how the robot behaved relative to another one. And maybe you don't get to fight a certain opponent that particular season. You might have to look at prior seasons or similarly designed competitors to get an understanding of how a certain design choice could interact with an opponent. One thing that was big for our team, as it lends to design, we're a sort of capture robot. And so we have a lot of our electronics, motors, compact in the back, and we want to leave a lot of space in the front so that we have that ability to corral. That makes a little bit of a design challenge because all of the mass of the core components is basically on the wheel axle right now. And so you can see from this photo is our center of gravity relative to the wheelbase, relative to the whole robot. I mean, this is a 2018 robot. It's pretty big. So from wheel to front tip, it's maybe 3 or so feet. In width, it's like 5 feet. And every single year, this is a challenge, something we keep track of to monitor that center of gravity such that when we accelerate, we don't have this reaction torque which lifts the front end of the robot up. So 2018 was okay. 2019 was a little bit of a struggle, but the previous years or the subsequent years, we have implemented other technology such as using the arm as a reaction torque mechanism to apply down force so we can keep the forks down at the front and then continually shifting the relative mass of things or the mass of items and position so we can get that center of gravity as far forward as possible.
So one of the questions we just had from Aaron Hill on YouTube, he asked the question, what do SawBlaze's new wedges look like? And I think this next image, this is your new SawBlaze. This is your new SawBlaze that you're working on right here. Is that correct?
Oh, this is a work in progress photo, so I wouldn't take too much from this necessarily. I know Aaron in particular, he has some interest in what that looks like. Aaron is another competitor who I'm good friends with, and we talk a lot about some of these design aspects. So he knows a little bit more about SawBlaze than some other folks.
All
but
right.
Yes, we are experimenting with different kinds of fronts, different techniques that we actually learned from Aaron as well. And some of these have appeared on the smaller weight class prototype of SawBlaze, which I know Jonathan is familiar with.
Speaking of Jonathan, I kind of want to, we want to take a look at Huge. Hey, we got a vote going out. Which is your favorite robot? But let's make sure we get a good look at Huge before we do that. Jonathan, can you talk to us kind of about how Huge has evolved over the years?
Yeah. So like everybody else was saying, it's definitely been a design goal of the process to keep the robot visually looking similar year over year. But every year we're pretty much remaking the robot from scratch. It's gone from the early days. It had, wheelchair motors driving it and pretty simple electronics to shrinking the body and making things more, or using more high-end technologies like brushless motors and nicer equipment to be able to make the frame smaller and reallocate that weight elsewhere. In our earliest season, we had really thin wheels. They definitely proved that they didn't have enough plastic in them. And then in subsequent seasons, we've been able to allocate more weight into the weapon, more weight into the some of the electronic systems, more weight into the wheels to be a better defense mechanism. And so while it is still huge, and while it still has the wheels, it has the bar, it's those things that can turn the difference between, having enough wheels means you win the fight, having not enough wheels means you lose the fight. And that's the kind of thing is on one hand, you always need to keep up with how the game is changing and how people are getting more powerful. So what was enough defense in 2018 is not enough anymore. But also it's just, we believe really deeply in the strategy behind the robot. And it's about optimizing things to hit what we see as the potential of that. And that's part of I think what everyone is always working towards with their robots, but it's the whole other side of the strategy. Yes, you can have great mechanical design and it can be the most serviceable robot in the field, but if your underlying strategy isn't something that can win fights, then that's that. I mean, you can have the best robot designed to drill through a top plate with a little drill, but it doesn't mean that little drill can make it through. thick steel or something like that. Like there's a whole separate tactical side of it that we really enjoy and that Huge takes a lot of advantage of.
Right. One of the things that you talked about when we met beforehand was this view of the chassis and making Huge more serviceable. I wasn't aware until I talked to all three of you why serviceability is so important. Can you kind of explain a little bit like how this design of the serviceability of these like motors has changed?
Yeah, definitely. So in our first 2 seasons competing, 2018 and 2019, the motors generally were bolted direct into the steel of the frame. And that made things a challenge for the sake of removing the motors from the robot. It's something you want to do between fights is inspect your motors, inspect your internal components, make sure there's no, cracks, nothing that's going to become a problem in a future fight. And in those years, it meant that we needed to split the robot in half, basically, just to get the weapon motors out. And that was a couple-hour job, basically. For 2020, we redesigned everything to be a pod-based modular structure. So right there is the 2019 one, which is, you still have to split it. And the 2021 with the pod-based modular structure it's so much easier. We just a robot. And then the idea is we have 5 of these on the shelf. So if there's a problem with one of them, we put it on the shelf to repair later and put in a good working spare. So that way we can always keep the robot ready to run whenever it needs to be. And then it's more of a spares management game than what it has been in the past, which is we have one of this motor and it's broken and we're running around looking for parts and asking people for help and whatnot, which was, we've, in our earlier years, we put a cardboard sign on the pits of like, we'll buy motor parts. We need, and it's just from the side of we need to be able to swap these things really quick.
Hey, I have a question here from YouTube. I'm going to ask it to all of you. It was really targeted at Jamison specifically. It's from Ryan Kisner on YouTube. It says, I like watching BattleBots. I even talked to Ray Billings on Messenger. I want to know which robot got you into BattleBots. For Jamison, which one inspired him to leave Overhaul? Ooh, was that a question I was supposed to ask? I didn't know.
Oh, I can answer it all the same, but we'll start with the first one. So definitely a huge inspiration for mine is a old Comedy Central middleweight named SOB. SOB, I won't say what that means, maybe, but it is another dustpan type robot. So it was, for its weight class as an aluminum structure, it had sort of these containing arms and more traditionally shaped like a dustpan you'd find in the household. So it had a floor on it and a similarly overhead attacking arm. So it literally scoop up robots and then cut them up. SawBlaze, heavily inspired by that design, but also not trying to build the exact same thing because we recognize that damage to the pan was hugely detrimental to the function of that part of the robot. Because imagine if you have a dustpan trying to sweep up little bits of stuff on your floor, and the front edge is damaged so it doesn't ride perfectly flat against the floor. You're probably not going to scoop much up. In fact, things will go underneath it and it really compromises the function of the capture control. So SawBlaze, the sort of design of the forks or the trident, whichever you want to call it, is a evolution on that concept because it's not so much about having a floor to contain, but it's having enough obstructions to isolate. And isolation from the floor is essentially what a dustpan will do. But for something where you're scooping up an object which requires control to the ground, this functions similarly, and if not more stiff and weight efficient. So that's where that comes from. And as well as the overhead type weapon, a traditional saw is difficult to implement. They're typically fragile, and for most cutting things, you want to have a controlled feed rate going into it to make a good cut. Otherwise, there's risk of damaging the blade or the associated mechanisms. So something that can do a rough cut very quickly that is also robust was something that we worked on. So the hammer saw technology that has come out on BattleBots that I've been developing for several years prior, is sort of our primary going forward. I kind of equate it as to getting a paper cut with cardboard, which is painful and gross. Now, why did I leave Overhaul? We are a community that likes to build robots. Overhaul was sort of a superstar team at that time of a lot of different builders that decided to group up together to build one robot. So after we got the start, we got familiar with the show, we all tried to do our separate entries, and that's really what it turned out to be.
All right. Brandon, what about you? Was there a robot or a moment that got you involved in BattleBots?
Probably the biggest inspiration for this robot specifically has been Biohazard from the original show. Took a very, very similar approach to how they want to fight, which is control the other robot, be incredibly low to the ground, lift the other robot up off the ground and flip them over. You don't have to throw a robot 20 feet in the air to win fights. You just have to take one more hit than they can take. And so that's been kind of our strategy, has been very, very heavily modeled off that. So, and there's not a lot of visual similarities, but it's definitely from a 10,000 feet is a similar kind of thought process.
All right. Jonathan, what about yourself? Was there a robot that inspired you to get involved in BattleBots?
In our case, so to get involved in the first place, we were mostly inspired by the original Comedy Central run of BattleBots. Had planted the seed when they brought the show back. It actually got us involved with the community and building little robots. But the idea for Huge came from a British robot actually known as Gabriel, which also uses extremely large plastic wheels. But where we have the support legs off the back, which are 3 or 4 pounds of plastic, they have like a 50-pound sword. So it'll do some damage. But I had just come off building a 30-pound vertical spinner at the time. I had all the spinner components, and I was watching Gabriel fight and thought, if I put a vertical spinner in the middle of that, we might be onto something there. And that was basically where the genesis of the design came from. And since then, it's just been, I think we've built like 10 or 11 in every weight class of Huges, and it's just been trying to further reach that optimized point of it really working how we intend it to. But yeah, that was the direct, I wouldn't say parent, but the inspiration behind the key feature. And then everything else, hanging the entire robot off the center shaft to mount the blade, the whole design style of the blade, that's pretty much just been pulled out of thin air because nobody had ever done anything like this before.
All right. Hey, I want to give a shout out back to you guys. You were talking about serviceability a little bit in your design process. Chris Dixon on Facebook says, glad to see you've done modular design. It's easier to repair and replace different components. We use a similar method on our EOD robots called wheelbarrows. So, even in that real world, that modular design is important for serviceability of those. So the results just came in here. Do you guys want to know the results of what's your favorite robot?
Absolutely.
All right. With 11% of the votes, in third place, P1. Sorry, Brandon. 34% of the votes in second place, we have Huge. And with 54% of the vote, SawBlaze at number 1.
Wow. Oh, I'm actually surprised that Huge is one of my favorites. I would have voted for Huge, but thank you so much.
Should have.
All right. I think you were running a social media campaign there in the background while we were doing got
like 18 people on his team, so I think.
Yeah. I want to go back to a couple more design elements before we talk kind of about getting involved in BattleBots here, because there was a really unique design challenge, Jamison, that you faced. In addition to managing the center of gravity, you were dealing with how to manage your arm, right? Like basically a clutch mechanism or something on that to keep the arm from breaking off?
Yeah, precisely. And that's part of that design iteration. So we talked about implementing changes based upon, say, feedback from previous seasons. This was one of them. And then 2020 season, we had 2 occasions where a reverse reaction would basically have broken parts of our arm weapon system, and that's immensely critical for the drivability and for delivery of said weapon system. So one of which was when Uppercut back drove our arm. Another one was when Tantrum ran our own weapon into the wall. and the forward direction. So decided, okay, we need to implement some sort of either a SEA, serious elastic actuator, or a torque overload device, or actually both. So here's an early concept that we've been playing around with to implement both of those things. It's a radial ball detent, radial pin detent style clutch. We tried to fit it in the exact same envelope as the existing sprocket mechanism, which was incredibly tight, and we needed to deliver over 400 foot-pounds to this thing for self-righting, weapon delivery, and for that secret, not so secret lifter if we need to. So you can see on the left here is actually a bird's eye view of what that looks like. We have the sprocket, and then we also have the driver, and on the right side, and we'll just go quickly through that, we have an image of what it actually looks like on the inside. The clutch elements are these pins that ride into slots and are forced down by, in this iteration, a flexure spring type design. So it's a 3-point bending thing. We needed a lot of stiffness in a small amount of area, and it basically pushes these hardened pins against another hardened steel surface, which are these detents. And the following video, you can actually see an early test of this functioning. So first we do some motion just to see everything is coordinated, that it's synchronous. And then afterwards, we'll actually run it into a stall condition, which in this case is bottoming out against the chassis. And you can see the driven mechanism rotating relative to the driver. So basically illustrating that this proof of concept is functional. Now, getting all the details for it to work, that's been at the torques required is the more difficult part. But that's part of the challenge. We're in the business of solving problems.
You've used a lot of SolidWorks tools to solve this. I think you had mentioned you had to use SolidWorks simulation to kind of figure out how that detent was going to work on there. Is that correct?
That's right. I mean, clearly from the images we can see we use SolidWorks modeling for that. Yep. We also use SolidWorks simulation to experiment with a bunch of different springs. So we had a cantilever style, then we tried the 3-point bending style, and at one point in time we even had a solid elastomeric material just to see what we can get. This is a high stress zone. So, some of the earlier concepts did yield, and, that's just the reality of it. SolidWorks helps us make these design changes, simulate them before we put big money into these prototypes.
All right. I love some of the, I want to make sure we cover a lot of the imagery and footage we sent there. So we were talking a little bit about testing, Jonathan, and one of the things you had mentioned, sometimes the first time you get to test these is, was it the pit, or what did you call this space that's kind of outside of the arena, outdoors?
Yeah, so they'll have 2 small test boxes available. Not small for most of the robots, but small enough that we really can't get a good drive around in there. But this is something at every BattleBots event, they'll have these boxes available for you to put your robots in and test. And in our case specifically, like, we cannot spin up that weapon and drive the robot around safely anywhere besides in a box like that. And even if you were to spin up a round toothless disc or something like that, there's still the danger of it storing a ridiculous amount of energy, but there's also, you can't account for wind resistance with a round disc with no tooth on it. And that's the type of thing where, you need to go and test it as it is going to fight and make sure if there's any last minute changes that need to be made to accommodate that you can make them on site, basically. So part of that is we've designed in some adjustability as well now to be able to help those changes on site. And then the other side of it is it's kind of just fun to play around in the test boxes. You get to flex out what your robot can actually do. That jump there was something we couldn't do in any prior huge before 2020. And it's a tactical move that if somebody's wider than the wheels, we can use that to jump on top of them. We can use it to escape situations. And it's a feature for sure. And that's the type of thing, you'll see smaller vertical spinners, they'll have a move when they're upside down. If you turn really hard to one side, it'll self-right itself, kind of like a rolling back over. And you'll see, Minotaur, Black Dragon, the vertical spinners out there for 10 minutes that they'll flip it up, walk in, flip it upside down, rev up the weapon, self-right. Let's just practice it. Because again, it's not like you can do that in a parking lot safely.
Right. Especially with
That's, and when you watch the
spinning
fight,
that
you
fast.
see him do it in 2 seconds and it's no big deal. And it's because it's a practice thing. And that's what, part of what the boxes are for.
So we are kind of getting near the end here. I want to talk a little bit about like involvement. So you've all alluded, you've worked on your designs, you've competed in 2020. There's been no announcement yet. Are you guys, I have to imagine you're chomping at the bit, all of you waiting for an announcement for the next season. I'm guessing. Fingers crossed. I see there. Look, Brandon, we can clearly see that you're like, I'm anticipating this is going to happen. I'm getting ready for the big game.
Certainly
There better
hoping.
be.
One of the things, so BattleBots itself is a big, very public arena that a lot of people can see. One of the things that I wasn't aware of is this is actually just a class of robot fighting, this 250-pound robot fighting. One of the things I was going to ask is, what do you do in your free time? And I think talk a little bit about like how you've like looked at some of the lower weight classes, or share with our audience that there are other ways to get involved in BattleBots that don't require this massive investment of time and money. Brandon, I think you mentioned you spent a lot of time in this. Can you talk about the 312 and 30-pound classes and maybe how they're easier for people to like take a look at and not be so intimidated by the big robots?
Yeah, so the big thing, so it's a lot like boxing in that there's weight classes. The primary number one rule for each class is you have to be under some specific weight. For the TV show, it's 250 pounds, but for most local events, they'll run little sub events for 30-pound robots, 12-pound robots, and 3-pound robots. There's also 1 pound and 150 gram, and sometimes even smaller. And there's sometimes maybe event specific rules. So you'll have to kind of check up on the rule set for your specific event. There's no overarching ruling body that controls all events or anything. But it's a lot of fun. And I personally like the 3 and 12-pound weight classes more than I do the 250-pound weight class, because if you can try a million different things, you can try all kinds of crazy different designs, and if it wins and you enjoy it, then great. And if it doesn't and you don't enjoy it, then you can fastball it into a dumpster and make a new one. And it is way, way, way more inexpensive, and you fight a lot more, sometimes exponentially more. With BattleBots, you could fight 3 times over the course of a year. I have 3 fights. And at most small robot events, you are guaranteed at least 3 fights, if not more. And you can go to 7 to 10 events a year. So you could end up fighting 35, 40 times over the course of a year. So there's a lot more time to iterate and a lot more time to see friends and meet people, and a lot less expensive.
That was a question we had quite a while ago in chat. I think it was Dallas Salad asked this question on YouTube, and I'll throw this out there. And if you're not comfortable answering this question, that's fine. I mean, how much does it cost to get involved in this? And maybe give us some perspective, the 250-pound class versus, say, a 3 or 12-pound class, because one of the questions I'm going to ask next is how can people get involved in BattleBots? And I think these lower weight classes is a good entry point. So Jonathan, why don't I throw this to you? Give us some sense of difference of scale and cost. Brandon alluded to it, that there's a significant difference, but can you give us some idea? And maybe is a lower weight class a good way to get involved in BattleBots?
Absolutely. Much like how the weight of the robots grows exponentially, as does the cost. So getting involved at the 3-pound level, we have Tiny Huge, 3-pound version, and I think it costs $300 to put together. And I've fought it at dozens of events. That's how we got our start in combat robotics. That's how we built our experience in combat robotics, and it's how we learned how to make, how to shape the robot in a way that would be effective. We've also competed at the 30-pound level with it, and then the 250-pound level with it. At the 250-pound level, robots, your general spend for a season is going to be like mid 5 figures, somewhere around there. And it's, some people are a bit more adventurous with their budget than others. Some people work to a much tighter constraint based on their resources. But we want to have 2.5 robots ready there to fight with. there's travel to cover, there's, shipping, there's meals, there's rental car. It really all adds up beyond just the cost of the pure robot. And I also can't control the fact that the plastic, especially the newer upgraded plastic we use in 2020 for our wheels, it's $1,000 a wheel. Like, there isn't really a way around that. And when we want to use the best material to have the most effective robot, that's just, it's a brick wall you got to put your head through sometimes. But I think the lower weight classes are 100% the best way to get into it, because I think that you're going to make so many mistakes building a 250-pound robot as your first time building any shape of a design that there's so much of the money that you're just going to have to replace the parts anyways when you realize you want to change it as soon as you fight it the first time. And an additional note is that the most consistently successful way when applying to BattleBots to actually get on is to show them video of a 30 or 30-pound robot that's that shape doing something cool and unique and effective. And that's exactly how we got on. We built a 30-pound huge, got second place at its first event to Jamison. We've won other events with it. We've been really competitive at other events with it. And when we showed them a video, they said, that doesn't look like it'll work at all. And here's all these videos of it working. So please come compete and see what happens. It's a totally different dynamic, because it's confidence for us as well, versus this might work. You should let me on your TV show to come find it. Because in 90% of cases, it doesn't work. So that's the type of thing, is you can test out a design, and if you think it's, your genius design, you may be able to find out it's not so genius at a private event that no one sees, versus on a TV show as well for a lot less money.
Yeah, I'll finish, Jamison. I'll go to you. You had mentioned to me that you've been involved in robot competitions for a very long time. If people are interested in getting involved in robotics in any way, what advice could you give them? You have a ton of experience. What are some of the entry points?
Yeah, I mean, really, it's just getting your hands dirty. You have to, go past the initial fear of, I'm not super sure what I'm doing, be humble about it, ask around, and just start putting something together. My first robot, granted this was like maybe 16 years ago for fighting robots, was made out of some, scrap gear motors that my dad brought me one day. And we used some Home Depot angle aluminum and some zinc plated steel off of old ducts from dumpsters. That was all taped together in hot glue. By the way, those are viable building materials in the smaller weight classes. And it's as they say, fail early, fail often. And that's really how best someone can learn. There's also a number of kits that different builders have turned into that you can buy. Probably some of the most prevalent ones are like the FingerTech Viper kit and the some of the bot kits products, or the NBots Vector kits. Those are 3-pound robots, the latter ones. And those have like a sort of compartmentalized building experience, so that you can learn the basics, put together your first robot, compete, and then really figure out a starting point to ask those questions. How can I make this robot better? In what ways is it good? In what ways is it bad? And then get your foot into the door to talk with other builders. You'll see, myself, Brandon, Jonathan at some of these smaller weight classes, and feel free to ask questions. We're more than happy to help.
So I think we have a couple URLs. So one of the things I want to be cognizant of, we're going over a little on time. We have a couple of URLs that people can go learn about where these lower weight class competitions are taking place, how they can get involved. I think, Jonathan, you had mentioned to me, like, that's a great way to get an understanding of like, how big is a 3 or 12-pound robot? And then Brandon, you shared a couple URLs with us. I think we're going to post these in the chat right here. Do you know what those are off the top of your head?
Yeah, so the first one is robotcombatevents.com. And then the other one is buildersdb, as in buildersdatabase.com. And yeah, the big thing is just like, even if you don't have a robot, just go watch. Just going and seeing how big robots are, how big they are, what materials they use, what motors they use, what speed controllers they use, will give you a huge leg up in building your first robot.
All right. Well, I want to thank all of you, Jamison, Brandon, and Jonathan, for joining me here today. This was really cool to give some insight into kind of how you design, what the community is like, and in different ways maybe you can get involved. For those of you watching at home, if you're not aware, we do broadcasts every single Thursday at 11 a.m. Eastern time. SolidWorks Live is about every 4 weeks, but next week we are going to have Andrew Gross on SolidWorks Live Design, where he's going to be creating an assembly of a mountain bike and then virtually test this new rear suspension. If you don't know, Andrew's usually running live design in the background for us. So this is going to be a really fun opportunity for Andrew to get up and show us some really cool stuff. And then, as always, SolidWorks Live will be coming back next month, August 5th at 11 a.m. Eastern time. We've got a bit of a surprise topic coming on that one. So if you don't want to miss any of these episodes, including Exploring 3D Experience SolidWorks, as always, make sure you hit that subscribe button on the YouTube channel. And then if you hit that bell notification icon, you'll get notified every single time we go live. I just saw that in the chat. Somebody didn't see the notification come through. That bell icon will make sure you never miss an episode. And as always, I want to thank everybody for joining us here. And until the next one, we'll see you next time.